Okay, we're going to jump straight into the examples here. It's solving quadratic trig equations. So, first thing you've got to do is solve the quadratic part of the equation, and then you're into doing your cast diagrams. So in this one, what a lot of people find easy is to let y equal sine x. So you could rewrite this equation as 2y squared minus 7y minus 4 is equal to 0. And then we can go ahead and solve this. So this is using your sum and product. We're going to solve it. Sometimes your sum and product won't work, by the way. You'll have to use your quadratic equation, quadratic formula. But here, the sum and product will work. Because our sum is minus 7, our product is minus 8. And minus 8 is the same as minus 8 times positive 1. So we'll rewrite our equation as 2y squared minus 8y plus y minus 4 is equal to 0. Factorize the first two terms, so it's 2y upon y minus 4. Factorize the second two terms, so it's 1 upon y minus 4 is equal to 0. You know you're on the right track because you've got the same common bracket. So y minus 4 upon 2y plus 1 is equal to 0. And then that means your y is equal to 4 or your y is equal to minus a half. Right, we have just invented this y in this question, so we have to rewrite this thing in terms of your sine. So here we have sine x is equal to, sorry, this thing keeps playing up this pen for some reason. Sine x is equal to 4. Sine x is equal to 4. And here we have sine x is equal to a half. Oh, minus a half it is. Now it's very important, that minus. Right, sine x is equal to 4. We should know from our original graphs we did in 2 videos ago when we looked at our sine, cos, and tan graphs, sine ranges from 1 to minus 1. So sine x equals 4 is impossible. So if you get this in the question, this is a good thing, this is not a bad thing. Just write down IMP, which I will know stands for impossible, and you can ignore it. So from here, we'll just go up here and we'll look at this one. So what do we have? We'll write it down again just to make it clear. Sine x was equal to minus a half. And then you want to do your basic angle. So to get your basic angle, I'll show my working out. It is sine to the minus 1, not of minus a half, but of a half just. And if you do that, you will get 30 degrees. And now we're on to our cast diagram. So for your cast diagram, C, A, S, and T. And as I say, I very rarely put the markings on it, but I will do that for you now. So it's 0, 90, 180, 270, and 360. And you look back, your sine x was minus a half, which is negative, and sine is negative in here and in here. So in the T quadrant and the C quadrant. So you mark on your 30 degrees with that horizontal. And this pen is going crazy. And then that's going to be 30 over here as well. And normally I would do this in red, but I'm scared of this thing imploding. So we will just, it's going to be in here. So it's going to be all the way around to this bit, or it's going to be all the way around to this bit here. So what you've got your two angles in this case are going to be x is equal to, so one of them was 180 plus 30, which is going to be 210 degrees, and the other one was 300, it was 30 degrees short of a full turn, so 360 minus 30, which is going to be 330 degrees. And there's your two things done. Okay, our last example of this type, which is a bit easier actually, it's solve 3 tan squared minus 3 tan squared x minus tan x equals 0. So I'm just going to write that out again. That's 3 tan squared x minus tan x equals 0. I'm going to show you don't have to do it the way I did in the previous one. So I don't have to say y is equal to tan x in this case. I could just take a tan x outside a bracket, which leaves me 3 tan x minus 1 is equal to 0. Now you're in this nice situation in mathematics where you've got something times something else equals 0. So if you had a times b equals 0, that means a is equal to 0 or b is equal to 0. So here, tan x equals 0 or 3 tan x minus 1 is equal to 0. So we'll just sort this second one out. That means tan x is equal to, the 1 comes across and then the 3 comes across, so 1 comes across and then the 3 comes across and divides. So your tan x equals 1/3. So tan x equals 0, that means x is equal to 0. So x is equal to 0. Let's just draw a wee cast diagram out. So how you've got that, you can even do that in your calculator. Tan to the minus 1 of 0 is equal to 0. Where 0 is on your cast diagram is here. Where it's also going to be equal to 0 is going to be at 180 degrees or minus 180 degrees. But if you look back on your range, you're not actually allowed to be minus 180 degrees or positive 180 degrees. So 0 is the only one that you've got. So far you've got x equals 0 and that's it. In this one, you'll have to do your basic angle. So we're going to do our basic angle here for this one. So your basic angle, so tan to the minus 1 upon 1/3 gives you 18.43 degrees. And then again, we've got to do our cast diagram, C, A, S, and T. And tan is positive, so it's going to be in here or in here. So 18.43 degrees and 18.43 degrees. So again, with the horizontal, and it's going to be this one is a positive one, and this one is a negative one. So my answers for these two, x is equal to 18.43 degrees, or it's going to be minus 161.57 degrees. Okay, read the question again. Have I listed all my answers? I have. I've got all three down. I've got 1, 2, 3 here, but it's maybe just not nice to have them there. I'm just going to list them. So my answer, x is equal to, I'll list them in ascending order, minus 161.57 degrees. I've got 0 degrees, and then I've got 18.43 degrees. Okay, folks, you're now ready to do the following questions. So it's the solving quadratic trig equations, questions 1 to 5.